With paper 1 out the way, it's time to turn our attention to paper 2. So today's video covers my top 4 tips for GCSE Maths paper 2 revision. Tip 1, my paper 2 revision checklist. Using the link in the description, go to my website and download my paper 2 revision checklist to identify the topics that you need to prioritise. Then work through those specific video lessons available for free on my YouTube channel. Tip 2, my paper 2 practice booklets. Once you've worked through the YouTube lessons identified by the revision checklist, then you need to work through my paper 2 specific practice booklet to solidify your understanding of the topics in preparation for the exam. Tip 3, my paper 2 practice papers. The night before the exam, it's time to complete my paper 2 practice paper to refresh your understanding of the topics that I'm guesstimating will appear on paper 2. Tip 4, my rapid revision system. Alternatively, if paper 1 didn't go as well as you were hoping, or you just need a time-efficient solution due to the other subjects that you need to revise for, then you should sign up for my rapid revision program upgrade, as it combines all the benefits of the previous points but turns them into a personalised revision plan for paper 2, which means that all you need to do is complete my paper 2 revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid programme, but if you sign up for 1 month now, then you'll get priority access to both my paper 2 and 3 specific revision resources. Sign up for a free trial of Upgrade today. Okay, so looking at our first question, we're going to look at using a calculator. And whenever you are doing a using a calculator question, you need to replicate what's on the page on your calculator screen. So for this question here, we would start by using the fraction button and then typing it in exactly as we see it using our power button. You can use the squared button or you can use the empty power button, which I'll use in just a second. We've got our square root button we need to know how to find. And then again, just typing it all in, just being careful if you need to come out of the square root. But once you've done that, we can write our answer out. This one wants it to 4 significant figures. So we'll chop that after our 4th number and round it as we need to. Okay, so this question says Owen uses a code to open a lock. The code is a letter followed by a 2-digit number. The letter is L or U, and the number is a prime number between 20 and 30. Write down all the possibilities. So the prime numbers between 20 and 30, we just need to think about the odd numbers between 20 and 30 that don't divide by anything. So 21 divides by 7 and 3. 23 doesn't divide by anything, that's prime. 25 divides by 5. 27 divides by 9, and then we have 29. So we only have a few numbers that are prime between 20 and 30. So in terms of listing the sort of possibilities that we can have here, we could start with the L or the U and then put our prime number with it. So we could have 23 alongside the L, and we can also have 29. So 2 of the codes could be L23 or L29. We can have exactly the same numbers, but with the other letter. So we can have the letter U, which could go with 23, and we can have the U, which goes with 29, and there's our possibilities for Owen's code. When we have indices and we are dealing with numbers, we could be asked to write the value of this. However, if we were asked to write the value here, we could just type this into a calculator. But this one says write it as a power of 3. So if we're going to write it as a power of 3, it's easier for us to apply our index laws. So when multiplying, we can add the powers. So on the numerator there, we can simplify that 3 to the power of 7 times 3 to the power of negative 2 by adding the powers. And not forgetting, you can use your calculator for those negative number calculations. So we need to do 7 add negative 2. You can do that on the calculator, but it comes to 3 to the power of 5. We then have 3 to the power of negative 3 on the bottom. Now, when we are dividing, we can subtract the powers. So the next calculation that we need to do is 5 take away negative 3. And again, you can type that into the calculator, but 2 negatives next to each other like this turn into a plus. So 5 add 3 would give us the power of 8. So we have 3 to the power of 8. Now the question here does say to leave it as a power of 3, so our final answer would be 3 to the power of 8. That's all that leaving it as a power of 3 means. When looking at the lowest common multiple, we can approach this question in one of two ways. We can either start by listing multiples of each number until we get that first matchup. So we could write 40, 80, 120, 160, 200. Typically, I'd write at least 5 and then we'd move on to the other side. So now moving on to the 56s, we get 112 and then 168. And at some point you're going to see that, of course, we're going to go past that 200. So 224, add another 56, gets us 280. And this is going to match 240, 280, and we have our lowest common multiple. Now, if the numbers are slightly higher or a little bit more complicated and you think the list is going to go on for quite some time, you can write these numbers as a product of prime factors. So 40 would be 4 times 10, and then we have 2 times 2 and 2 times 5, and then we can go for the 56, which is 7 times 8, and then keep going with your 8. And there we go. So once we've got these as a product of prime factors, what we do is we have a look at our list and we match up what's in both. And you can write that out as a long list, or you can do it from your prime factor tree, but both of these have a 2, they both have another 2, and they both have another 2. So anything that's in both, we'll times those together. So 2 times 2 times 2, and then have a look at what's in the numbers on their own. We have a 5 and a 7, and then we just do times 5 times 7. I can type that in on the calculator. So 2 times 2 times 2 times 5 times 7, click equals, and we get the answer 280. Now our next question is looking at standard form. If we're asked to write a number in standard form, you can just type it in on your calculator. Now it might not always give you the standard form version, but you can convert it and have a look. And if it doesn't, don't forget you can always hop the decimal in and just remember it's a positive power for a large number or a negative power for one of these 0-point numbers. For a larger question, when we have to type quite a lot in, you may have to use your fraction button, but we just want to replicate exactly how it looks on the screen, and not forgetting this button here where you can put any power in. Remember to come out of the power by pressing that right key, and then you can type in the rest of everything there. Remembering that if you have a negative power, like we have on the bottom here, you can use either the negative button or that subtraction button to put that negative in, but I do tend to always stick to using that negative button here, so I just don't make any mistakes as I'm going along. But here we go, clicking equals, we've got our final answer, and we can write that down in standard form, and there is some standard form. And looking at some percentage change. Now this question says Liam paid £245 for his insurance, and the next year it went up to £883, and it wants us to work out the percentage increase. Now whenever we're looking at a percentage change, whether that's an increase, decrease, a profit or a loss, we'll always tend to follow the same approach. We'll first follow the actual, or work out the actual monetary increase, which has gone from 883 from 245. So if we subtract 245, we have £638 increase. Now whenever we're working out a percentage change, we just do the change divided by the original and multiply that by 100. Now you can see in this question that the actual amount that it's increased by has gone up by more than 100%. It's over doubled. So we are going to get a large percentage here, but let's put the numbers in and see what we get. So we have 638 as the change. The original was 245, and we're going to multiply that by 100. Now you can type this in 2 steps, or you can type it in as a fraction and just put it all in one go. That's how I'm going to do it. And I get quite a strange decimal here. It comes out as 260.408163 and a few more decimals. Now this question doesn't say to give your answer to a certain amount of decimal places. Now that doesn't mean that you've gone wrong, so you shouldn't be put off by numbers like this. Typically, in a question like this, I would just write down every number on my calculator screen. I would stop after 7 decimal places because some calculators only go up to 7 decimal places. So if we were going to write this, and you can use your S to D or decimal conversion button on your calculator, but for me, to 7 decimal places, it comes out as 260.4081633, and I just leave it like that. If it asks me to round the answer, then I would, and it does feel a little strange in a question where it doesn't say something like round or give your answer to 1 decimal place. But there we go, as long as you are confident that you have done your method correctly, you've gone back, you've double checked it, sometimes numbers like this can appear in a question. Now this question, we are looking at an error interval. It says the length of a pencil is 126 millimeters, correct to the nearest millimeter. So the first millimeter is this units here, the 6, so it's correct to that 6. So it's 126, but it could be point something, it could be just below. Now this asks us to write down the error interval. Now it can help to draw a little number line here, but to get the upper bound, the number on the right, we actually have a nice or relatively easy process to get that. Now the next millimeter above 126 is 127, and below 126 is 125. With an error interval, we're looking at those cut-off points or those midway points between those numbers. Now, in between 125 and 126 is 125.5. And in between 126 and 127 is 126.5. So they are the bounds that we're going to put on the left and right within our error interval. So we're just going to put the 125.5 on the left and 126.5 on the right, and there's our error interval. When looking at collecting like terms and simplifying general expressions like this, we just need to be careful, particularly on this part B question where we have some powers involved. Now on the first one, we have simplifying 5p, take away 3p, and then plus, and we just have this letter p. Don't forget, although it's not written, there is a secret 1 in front of that p, so just remembering to count those up as we go. Now we want to simplify this so it's just one number in front of p, as we only have that one letter there. So first start by doing 5p take away 3p, which leaves us with 2p, and then we are going to add 1p. So 2p add 1p leaves us with 3p in total, and there we go, we've simplified that. For the next one, we have m cubed plus m cubed, and again, the fact that these don't have the secret ones written in front of them might accidentally throw us into thinking that this is an index law rule where we have powers. Now this is not all we are doing, we're collecting these, we're saying how many m cubes there are. Well, you can see there's 1m cubed plus another 1m cubed, and in total that is 2 lots of m cubed. Not to be confused with a question where we are doing m cubed multiplied by m cubed. And in that circumstance there, we have the index law of adding powers. So this is a very different question, so be very careful. This is the scenario where it would turn into m to the power of 6. For our final question, we have simplifying with different letters, and we have a number in there. So if we have a look, we want to look for the like terms. It doesn't matter which one we start with, but one thing that stands out is there is only one number in this. So we'll stick with the number, which is going to be 10. We then need to have a look at either the C's or the D's. I'm going to start with the C's as it's written next, and not forget to include that symbol that's written in front of it. So here I have 3C, and I have a minus 7C. Now I have a positive and a negative there, so I'm just going to type it in on my calculator. 3 take away 7 is negative 4. So that leaves me with negative 4c. If you're not 100% confident with negatives, just use your calculator. We are practicing for using a calculator with this video, so we're going to use this at every opportunity. For the D there, we have 5d and we have 1d, again writing that 1 in. Both a positive, so that's a nice one. We have 5 plus 1, which is plus 6d. And there we go, there's our final answer, 10 take away 4c and plus 6d. For this next question, we have some substitution and changing the subject, and we have quite a difficult formula up here, in the sense that we have 4m squared. Now, before we look at what we need to substitute into this formula, we just need to think about what 4m squared means. It means 4 times m squared. And when you think about your order of operations, you always do your powers first. So the first thing that we need to do is do this m squared, and then we'll worry about the 4 multiplied by that and then taking away 11. So here it's asking us to substitute -3 into m. Now when you are substituting a negative number, you need to make sure that that number goes in brackets. So when we are doing m squared, if I do this, I write this out in one go, we have 4 times in brackets -3 squared and then minus 11. As we're using a calculator, we can actually now just type that all in one go. You do need to write the -3 in brackets though. And if you have a calculator in front of you, you can test this out. We get 25. But if you test out writing in -3 squared and just -3 with no brackets squared, you'll see that you get very different answers. When you do a negative multiplied by another negative, the answer is positive. So we get +9. However, if you type in -3 squared in the calculator, you will get -9, which is incorrect. And that's purely because your calculator will do the powers first, and then it'll do the negative version of that, as your calculator follows the order of operations. So do make sure you put a bracket around any negative numbers when you are putting them in the calculator. For part B, it asks us to make P the subject of the formula. And it's a relatively nice formula. We just need to first do the inverse by getting rid of this 4. And to get rid of the 4, we would subtract 4 from both sides. That means we get the expression on the left, d minus 4, and that's now just equal to 3p. To get rid of that 3, we have to divide by 3. And when we divide by 3, it creates a fraction on the left. It gets rid of the 3 on the right. And we just end up with d minus 4 divided by 3, and that is now equal to p. P is now on its own. It doesn't matter whether P is or the subject that you're looking for is on the left or the right of the equal sign. It's now on its own. Typically on a dotted line, it might say P equals and then give you the dotted line. And then in that situation, we would just write d minus 4 over 3 and just swap those pieces over. Now for this question, we are looking at some laws of indices. So we mentioned a question earlier where this might have tricked you when it was a plus in the middle, but here we are multiplying and we have the same base letter. So when we have this situation, we can just add the powers. So we would just add the 3 and the 5, and that would give us n to the power of 8. For the next question, we are dividing, but we have 2 different letters involved, and one of those doesn't have any power written with it. So that D on the bottom doesn't have a power, so we'll just put in the little secret power of 1 that's written in there, and then we can actually go about subtracting the powers here. So looking at the C's to start with, and do look at them separately, I'm looking at the C to the power of 3 divided by the C to the power of 2. Now when we subtract the powers, that leaves us with C to the power of 1. You can write the power of 1 in if you like. You're not going to gain marks or lose marks if you write it or don't. But typically you won't see that power of 1 written anywhere. For the D, we have D to the power of 4, and then we have D to the power of 1. If we subtract those powers, we end up with D to the power of 3. Typically I wouldn't write it with that power of 1, so I would just write CD to the power of 3. And there we go, there are our laws of indices when multiplying and dividing. Now we have another law of indices here, but we're primarily focusing on expanding and factorising in this question. Now when you have powers in brackets, all you need to do is multiply the powers. That's a quick trick really, because x to the power of 3 to the power of 5 actually means x to the power of 3 times by itself 5 times. Now it would be a long process if every single one of these questions we wanted to rewrite it, but as a fail-safe method, you could write it out 5 times, and then we just add up all those 3's. If you add up 5 3's, that's just the same as doing 5 times 3. So our answer is x to the power of 15. For the expand question, we have 2 sets of brackets, and noticing in that second bracket we have 4 minus 2x, which is always something that might throw you. So just be really careful here. We are multiplying the first bracket by 4, and that would become 4x plus 12. And the second bracket, we are multiplying by 7. So 7 times 4 is 28. That's going to be positive 28. So plus 28. And then 7 times minus 2x will be minus 14x. Now that's the expand part. We now just need to simplify and collect the like terms. Again, it doesn't really matter here which you collect first. However, having an awareness of the symbols here might just encourage you to add the numbers together first, because we have 12 add to 28, which is equal to 40. And then we have the 4x minus 14x, which will give us a negative. And it's just a little bit nicer looking if we put the negative in the second place here. But we can type this into a calculator. 4 take away 14 is minus 10 or negative 10. So minus 10x. You don't have to write it that way around. If you did the x's first, you could have written this as minus 10x. You'd have then just had plus 40 with it. We just have that one extra symbol. Either way is absolutely fine though. For part C, it asks us to factorise fully. Now when it says this word fully, it does mean there's more than one thing that can come out. Now if it just said to factorise it, we could actually just take a number out, or a letter. Which means if we look at these pieces, we could spot that they both divide by 3. And you could just put 3 on the outside of the bracket, and if we did that, we would have 5x cubed, which is what you have to multiply by to get to 15x cubed, and then you would have x squared y, which is what you need to multiply by to get 3x squared y. So worst case scenario, that would get you 1 mark on one of these more difficult factorising questions. However, when it says to factorise fully, we do need to try and see if we can spot a number and anything else that goes out the bracket. So we already know 3 goes outside the bracket, and this expression has an x in both, and actually there is a highest power of x squared in both. The one on the left is an x cubed, but we have an x squared on the right. So we can actually take out a power of x, which is to the power of 2. That does make this question quite tricky. But now if we think, what do we times 3x squared by to get to 15? Well, that's going to need a 5. Will that turn into an x cubed? No, would need another x with the 5. We keep the symbol the same. What do we times 3 by to get to that 3 on that right piece? Well, that's just 1, so we don't need to write it. X squared is already in that as well, so we would just need to put a y in that second part of the bracket. Now there are probably 4 or 5 different ways that you could factorise that particular expression. It's quite a difficult one. But fail-safe method, just make sure you always factorise a number out at least, just to make sure you guarantee at least 1 mark on the question. But there we go, there is the factorised fully version to finish it off. And on to expanding and factorising quadratics. So here we're going to start with expanding and simplifying a double bracket. So we have 4 multiplications to do. We're going to first multiply the 5x by both pieces in that second bracket. 5x times 2x will give us 10 with x squared. And 5x times negative 3 is negative 15x. We can then move on to the 2. So 2 times 2x, and that's positive 2 times 2x, so positive 4x. And then positive 2 times negative 3 makes negative 6. We can then collect together these middle terms, and we have 10x squared at the start, negative 15 add 4, and in this circumstance here, remember to use your calculator, negative 15 add 4, which is just negative 11, so negative 11x, and then minus 6. And there we go, that's our final answer, and typically most double brackets will look like this when expanded. They will usually be in this format where we have an x squared piece, an x in the middle, and a number at the end. On to part B, where we are factorising. In this circumstance here, we want to find the numbers that go into our double bracket. They both will have an x at the start, as it's again just an x squared at the start of this quadratic. We want the numbers that multiply to make 12, so we could have 1 and 12, 2 and 6, or 3 and 4. We are looking for the pair of numbers that add together to make 7. That pair of numbers is 3 and 4. You can do a process of elimination going down your list, but that is plus 3 and plus 4, and they can be written in either order. Other than these two, there is another type of quadratic which is worth knowing about, where you have an x squared minus something like 16. Now in this circumstance there is no x piece in the middle, and that's because this is called a difference of 2 squares. And this is the one situation that's slightly different to both the ones on the screen. When factorising a difference of 2 squares, you are looking for the numbers that multiply to make 16 but will combine to make 0. and that is always going to be the pair of numbers that are identical. And in this case, that's 4 and 4. The only difference being one is plus 4 and one is minus 4. So that's the one unique scenario outside of these where you have a difference of two squares. When solving quadratic equations, we take the same process of what we did before. We're going to factorise this quadratic. That means they both, or it goes into double brackets that both have an x in, and we just have this equals 0 at the end. We want to know what numbers times to make 24. There's quite a lot of options for 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then there are no more. We just need to find the pair of numbers here that combine or add together to make 5. You can make 5 using 3 and 8, except one will need to be negative. So if we have plus 8 and minus 3, they combine to make plus 5. Just being really careful with the symbols there. If we did the symbols the other way around, negative 8 plus 3, that would give us negative 5. Now when solving a quadratic, all we do is we look at these numbers within the brackets, and all we do is flip the symbols on them. So negative 8 for this one, and positive 3 for this one. Typically we will say x equals prior to that, so x equals negative 8, and x equals 3. A slightly harder, changing the subject of a formula here as we have this square root involved. Now if we have a square root involved in a formula and we need to get rid of that in order to unlock the subject, the way to get rid of a square root is to square both sides. Now if we square the left hand side, that becomes t squared, so that's quite nice. And when we square the right hand side, it's quite strange to write this. Really we should put the whole thing in brackets, but if I just put a little squared here, all it does is it just gets rid of that square root. So then when we rewrite it, we have t squared is equal to g plus 5 over 3. Now the next thing, locking that g in place, is this divide line. We have this 3 underneath, which means to divide by 3. So to remove this divide by 3 process, we would need to do the inverse, which is timesing by 3. So when we times both sides by 3, we end up with 3 lots of t squared on the left. We don't need to put the times sign, we can just write 3t squared. That's now going to equal g plus 5, as that whole multiplication by 3 just removed this divide by 3. There's now only one step left, and that is to get rid of that 5, so that g is the subject. To get rid of a plus 5, we will minus 5, and when we minus 5 from the left hand side, we have these 3t squareds, then take away 5, and that is equal to g. And again, if you have g equals on your dotted line, you would just write 3t squared minus 5, or you can write it either way round, 3t squared minus 5 equals g, or g equals 3t squared minus 5. When we have to draw inequalities on a number line, really nice to remember the circle, which we are going to draw above each number, just goes above the number or numbers in the inequality. Now in this first inequality, we have x is greater than negative 1. So we will put a circle above the negative 1, and we're going to point the arrow in the same direction that the inequality is pointing. Now, if you look at the way the inequality is pointing, it creates an arrow which points in the direction that we want to point our arrow. So we're going to point it to the right. It doesn't matter how far or how long along the number line you draw that, as long as it's pointing in the right direction. You just need to take into account that if the inequality has the extra line underneath it, you have to put some extra ink inside the circle and colour it in. Now this one doesn't, so we don't have to worry about that. And there we go, that's our number line that shows numbers greater than negative 1. For part B, we have a joint inequality where it is showing numbers between negative 2 and 3. So this time we have two numbers in our inequality, so we will have a circle above both, negative 2 and 3. We're going to join those together and we're pretty much finished. We just need to have a look and see if any of these inequality symbols have the additional line on. In this question, the one on the right has the extra line with our inequality, so meaning that it's also equal to. So all we do is we colour that circle in, and there we go, that is our inequality on a number line finished. Now when looking at the nth term of a sequence, we can have an increasing or a decreasing sequence. This particular one is a decreasing sequence. Now always have a look and spot what the pattern is between the numbers. This one's going down by 6 and then it's going down by 6 again. It tells us it's an arithmetic sequence in this particular question, but if it doesn't, just make sure you check. Now as it's going down by 6, all we have to do is put that number with the letter n. And it does say write in terms of n, that just means the negative 6 times table. Worst case scenario, in the case of a sequence like this where it is decreasing, which is more complex than when one is increasing, well, in this question we've definitely got ourselves half the marks. Now the negative 6 times table starts with negative 6. So all we need to do is think about how much bigger this sequence is than that negative 6. So I like to write that number above the first term in the sequence. Here we have the number 19, and then I'm thinking about sort of some negative numbers here, how I would get from negative 6 up to 19. Well, it's a jump of 6 to get up to 0, and then an additional 19 to get up to 19. So it's 6 plus 19, which you could also do on your calculator, and that is a jump of 25. So to get from the negative 6 times table to the sequence we've been given in the question, we would have to add 25 to our negative 6n. And there we go, that is our nth term. You could also write this the other way around. You could write 25 minus 6n, but you don't have to. But if you are given an nth term in a question, you might see it written the other way around. With simultaneous equations, we need to make sure the coefficients of either x or y are the same. Now my personal preference is I always go for the coefficients of y, so that I'm going to stick with that for this question. If you do the x's, that's absolutely fine. You can always stick to your method, but I always go for the y's. Now to do that, we need to multiply this top equation by 3 to make sure that we have 3y in the middle. Now that means everything gets multiplied by 3, so we would have 15x plus 3y is equal to 63. The second equation, we're not changing anything, so we'll just rewrite that underneath so that we can compare these two and see what we're going to do next. Now the next thing is I look at the symbols in the questions. If the signs or symbols are the same, you subtract the equations. You can remember that by writing SSS, same sign subtract. If the symbols are different, then you're going to add those equations together. So here we are going to add these equations together, and that gives us 16x is equal to, and we get 72. And not forgetting, we don't need to worry about what 3y add negative 3y is, because the whole point of this is that they're going to cancel out. Now in this question here, we get 16x is equal to 72. Now that's not the nicest of divisions to do, but of course we are using a calculator. So here, where we divide by 16, we're going to divide both sides by 16, and that's going to give us that 1x is equal, and we get 9/2 or 4.5. So we do get a decimal solution for this equation. With simultaneous equations, we also have to find the value of y. So I pick one of the equations that I'm going to substitute this 4.5 into. It doesn't matter which one you choose, but I typically will choose the one that has the positive symbol in, if one of them has a positive symbol. So 5x means 5 times x, which is 5 times 4.5. Again, we can do this on the calculator, so we don't need to worry about the fact that we've got some different or decimal type numbers. That gives us 22.5, and then we'll write the rest of the equation. Plus y is equal to 21. It's a relatively nice equation to solve. We just need to get rid of this 22.5 so that it says y equals, so we'll minus 22.5 from both sides of the equation, and that gives us 1y is equal to, and I'll just type into my calculator 21, take away 22.5, and I get negative 1.5. And there we go, that's my second solution. Typically on a simultaneous equation question, it will have the dotted line that will say x equals ... and y equals ... So just make sure you put them into the correct place on the dotted lines. So with identifying types of graphs, there isn't really an approach that you can use to work this out, so to say, but you need to just recognise what these types of graphs actually look like. So question or graph A here, that is an x squared graph. You have a positive and a negative variation of your x squared graph. This one, it makes this U shape. A negative x squared is upside down. It makes this almost N shape. So recognising those is your starting point. You then have to look at your cubic graphs. So cubic graphs are these ones here, where we have this almost wiggle in the graph, and there's another one just there. So both of these are cubic graphs. Now the x cubed graph on its own only has one root. It passes through 0.
So this one down here is the x cubed graph. The one in graph B just has some additional things along with the x cubed, but it still starts with x cubed. However, this one that we're given here, y is equal to x cubed, is graph F. Moving on to some other graphs, graph E is a straight line graph. So this would be y equals, and then maybe something like x plus, and then let's just make up a number, something like x plus 3, if the y-intercept here was 3. Of course, you can have a graph that's sloping downwards as well, and that would have a negative x value in terms of its gradient. The only two that are left over are our reciprocal graphs. So we have graph C and graph D. Now the 1 over x is a reciprocal graph. Now when we have part of the curve in this positive quadrant of the graph, that's where it's a positive 1 over x. The other graph, which we have over here, which is also a reciprocal graph, it has it in the negative quadrants of the graph. So this is where we have a negative 1 over x, or something along those lines. So here, this graph here is graph D. So with forming and solving equations, there are different types of questions that we can see. We can tend to have questions that have algebraic side lengths or potentially algebraic angles. Now this type of question here actually gives us the perimeter of the shape in a non-algebraic way. So we have the perimeter being equal to 52 centimeters. But on the diagram, all of the lengths, and the perimeter is the distance around the outside, is given to us in terms of algebra. So what we can do is we can add up all of these side lengths, 2x minus 5, x plus 1, x minus 1, and 2x, and set that equal to 52. So if we go round adding the x's up, I'll start with one of them, so 2x, and I'll go clockwise, so 3, 4, 5, 6, so 6x. And we have the numbers negative 5, add 1 is negative 4, take away 1 is back to negative 5, and then we have no number on that bottom piece, so minus 5. Now it tells us that that is equal to 52, and that's how we form our equation. Thinking about another concept here, if those were angles, they would equal 360, because angles in a quadrilateral equal 360. So we don't necessarily have to be given the answer, we could sort of have to know the answer if it's based on an angle fact. So here we can now go about actually solving this. So we can add 5 to both sides. Now when we add 5, we get 6x is equal to 57. Now in this particular equation, we now need to divide by 6. Now that's not going to come out as a nice whole number. So when we divide 57 by 6, ideally we don't want to write it as a fraction. Now if we have a calculator, of course, we can just type that in, so that comes out as 9.5. Now we could give the answer as a fraction if the question had said find the value of x. But this one here says work out the length of DC. Now d to c is the length here, 2x. So if x is equal to 9.5, well then 2x is equal to 2 times 9.5, and 2 times 9.5 is 19 centimetres. So there we go, that length there is 19 centimetres. And of course we could work out any of the other lengths. We could do the x plus 1, the x minus 1, we'd just use the 9.5 for those as well. But there we go, that is forming and solving an equation with perimeter. With Pythagoras theorem, we have a formula that we need to know how to use. So Pythagoras theorem is a squared plus b squared is equal to c squared. And whenever we see a right-angled triangle that doesn't have any angles involved, we should be thinking about Pythagoras theorem straight away. Now in this circumstance, we are looking for one of the shorter sides. So Pythagoras theorem is ever so slightly different when looking for a shorter side. In our formula, c is the longest side. So rather than adding the sides together, in fact we have to take the sides away from one another. You can rewrite the formula if you like. You can write c squared, take away either of a or b, because we haven't labelled the sides with letters, so it doesn't matter which one we write, we'll just write minus a squared, and that equals the other side squared. So here the longest side is always c, the other two are a and b, however you choose to write them. I'm just going to label the 4 as the a, and then we've got our b down here. So for this one, we would do 8.5 squared take away 4 squared. That's going to be equal to the answer that we're looking for, but the answer squared. So if we type that into a calculator, 8.5 squared take away 4 squared, it gives us the answer 56.25. Now clearly that side cannot be 56.25, so this should trigger your memory to remember at this point here you need to square root that answer in order to get to the length that we are looking for. So you just need to type it in. You can use your answer button to speed up a bit of time, but you will get the answer 7.5. That's 7.5 centimetres. Centimetres was already given to you next to the x, so all we would need to say is 7.5 for the value of x. And there we go, that's using Pythagoras Theorem. Now when looking at trigonometry, there's lots of different ways that people are taught this. You may write the ratios down, you may write formula triangles down. Either way is absolutely fine. Now for a formula triangle, as I know a lot of people use this method, if we are looking at SOHCAHTOA, we need to first decide which letters we're going to be using, and they refer to the side lengths. Now this first one here is asking us to work out the length of B to C. B to C is this length down here. That is the opposite side to the angle that we are going to use. The hypotenuse, which is the longest side, has not been given to us, but that means the final side, the 12, is called the adjacent. So here we have the opposite and we have the adjacent. And if we look at our formula triangles, the only one with O and A in is our TOA formula triangle, which means we're going to be using tan. So in this circumstance, you cover up the side that you're looking for, which is the O, and that T next to the A means we need to do a multiplication. Whenever you press sin, cos or tan on your calculator, a bracket will appear, and that reminds you to put the angle in the question into that bracket. Just don't forget to close the bracket. We're going to multiply that by the adjacent, which in this case is the 12, and then we just need to type that into the calculator. So tan 56, not forgetting to close the bracket, multiplied by 12, and that is equal to 17.79. Now there are more decimals, but it does say here to give your answer to 1 decimal place. So I'm going to round the answer from there, which is 17 point. After the 7 is a 9, so the 7 rounds up to an 8. So we have 17.8 centimetres as our final answer. Now for part B here, we are looking at finding the angle. So again, we need to follow the same steps. We need to label the sides. Now this time, the side opposite the angle has not been given to us, and it's not the one that we're looking for. So we're just going to label the other two sides. 18 is the hypotenuse, and 15 is the adjacent, as it's not the opposite. So we have A and H in this one. A and H is in our CAH formula triangle, which means we're using cos. When you are finding the size of an angle, again we're going to take the same approach. We cover up the C, and that means that we need to do A divided by H. However, if you type in A divided by H, it will just give you a decimal. And you can type it in 15 over 18, and you will see that you just get a decimal, comes out as 5/6, but that is not the angle. In order for the calculator to know that you're looking for an angle and not just doing a division, we have to press Shift cos, which will bring up the inverse of cos. We get cos minus 1. Again, when you type that in, it will open a bracket, and that just reminds you that that fraction needs to go in there. So if we put the fraction in, it would be 15 over 18. You can close the bracket if you like. It doesn't really matter in this particular one because nothing's going after the bracket, but it's always good practice to make sure you do close the bracket so we don't forget in other scenarios. So 15 over 18, and we get the answer 33.557. Again, it only wants my answer to 1 decimal place. So if we round that to 1 decimal place, we get 33 point. After the 5 is another 5, so 6. And not forgetting, this is an angle, so that is in degrees. There we go, we get 33.6 degrees as our final answer for that one. Now when looking at averages, there are 4 of course that we could be asked to look at, but here we're going to look at the mode and the mean. Now the mode is the most common number, and when the numbers have already been put into size order, it does make it really nice to see the mode. We can see over here that there is a cluster of 4 8s. So the mode, being the most common number, is going to be 8.
If the numbers are not in size order, it's always good practice to put them into size order just to help with other averages as well. Of course, we can see the range more clearly, the distance between the smallest and biggest, and we can see the median more clearly, which is the middle number. Now, the next part of this question is asking us to work out the mean. The mean is where we add them all together and divide by how many numbers there are. So in this question, we need to add them up and we're going to divide by 12, as that there are 12 numbers. Now, when you are adding these up, particularly when there are 12 numbers, just be really careful when you add them on the calculator. It's very easy to click an incorrect number or just forget to put the plus symbol between two of the numbers, and that's obviously going to throw your answer completely off. So as you're typing this in, it's all just about being really careful and accurate. Now, these all add up to 84. So when we type them all in, we can now divide by 12 and we'll get the answer 7. Just be really careful when you type this in that you first get the total of the list before pressing divide by 12. If you try and add them all together and just at the end of the calculation put divide by 12, the calculator, depending on which order you've typed them in, will do the division first. So you need to add them up, press equals, and then divide your answer by 12. Obviously, not always 12, but in this question there were 12 numbers, so dividing by how many there are. Now, when it comes to reverse mean, it's not always clear and obvious that you're going to be doing reverse mean. There's a lot of information in this question, but it does tell us down the bottom the mean amount of money per person is 80. And when it tells you the mean amount of money per person or the mean amount of anything per group of people, it means that we can find the total. So if we read this question, it says Jasmine has £65, Kieran has £100, and Samantha has 3 £5 notes, 1 £20 note, and some £10 notes. Now, there are 3 people. So if the mean amount of money per person is 80, then whatever their total is, which we don't know, divided by 3 would have been equal to £80. And this is the process of reverse mean. It's reversing that division that would have happened to find out what that total was. So to reverse this, if we would have divided by 3, we can times both of these by 3 to get our total, and then whatever that total is will be 80 multiplied by 3, which we can do on the calculator, and that was 240. So the total of the amount of money that these 3 people have is £240. Now, Jasmine and Kieran at the moment together have £165. So we can find out how much Samantha has by doing 240 take away 165. Now, I'm going to do this on the calculator, but do notice how I am still writing out the subtraction calculation here to make sure I get my method marks in a question. So Samantha has £75. Now, if we have a look at how much she has at the moment, she has 3 £5 notes, that's £15, 1 £20 note, so £20, and some £10 notes. Well, together, these add up to £35. So in terms of Samantha's money, when we know that she has to have £75, well, £75 take away £35 leaves Samantha with £40. And it says that she has some £10 notes. So clearly you can see, and 10 is a nice number for this, that that's going to be 4 £10 notes. But of course we could just write divide by 10, and that is equal to 4. So Samantha has 4 £10 notes, which would give her that additional £40, which would make her total be 75, and the total of everybody be 240. And there we go, there is a reverse mean question, thinking about multiplying the mean by the amount of people to get that total. Now, for averages from a table, you could have them as a grouped frequency table, or you could have a fixed number on the left. But if we're asked to work out the mean from a table, we take pretty much the same approach. Except with grouped frequency, we don't actually know the actual, and in this case it's about the time in seconds, we don't actually know the number that's going in that left column. So because we don't know it, we're asked to estimate the mean. And the way that we're going to estimate that is to find the midpoints of the groups. So here we're looking at the midpoint between 5 and 10. Now, if you don't know what the midpoint is, you can add those numbers together and divide them by 2. So adding them together is 15, and that gives us 7.5 when we divide it by 2. The next one will be 12.5, then 17.5, and then it's 22.5. Now all we're going to do is multiply across to find the total of each row. So there's one person at 7.5, 2 at 12.5, 7 at 17.5, and 8 times 22.5. So obviously using your calculator for this, and we're going to get the total of each row. 7 times 17.5 is 122.5, and then 8 times 22.5 is 180. Now we know the total of each row, we can get the overall total. So 180 plus 122.5 plus 25 plus 7.5 comes out as an overall total of 335. So to estimate the mean here, we want to divide the total by how many people there are. Now this particular question does tell us up in the words that there were 18 students. However, if it didn't tell us that, we would just add up the total frequency, and that tells us that there's 18 people. So now we can do the total, 335 divided by the 18 people, and we do have a big hint in the question here that we're going to get a decimal number, as it does say to give your answer correct to 3 significant figures. Now this actually comes out as 18.61, and there's a recurring dot above the 1. That just means the 1 carries on forever. So here, if we want it to 3 significant figures, 1 and 8, after that is our third significant figure. It's a 6 and then a 1, so that's going to stay as a 6. And there we go, there is our mean time. And if it didn't say on the dotted line, we would put seconds. And there we go, 18.6 seconds would be our estimated mean. And remembering, we can only estimate the mean here because they are in groups and we don't actually know the exact amount of seconds for each of those people. Now we're looking at a pictogram. It's really important with a pictogram that we have an accurate key. This particular question here says write down one thing that is wrong with this pictogram. Now looking at it, the pictogram is drawn properly and the key is drawn nice and neatly. So there must be something wrong with this key. Now over here we are allowed to use half of a circle. So what does that mean in terms of our key? Well, our key here says a full circle represents 3 CDs. Well, that would mean that half of a circle was equal to 1.5 CDs. Now that's impossible. You can't have 1.5 CDs unless of course you snapped one in half. But as this is about CDs being sold in a shop, of course we're not going to have 1.5 CDs. So we would just write something along the lines of the key here, half of a circle is 1.5 CDs. You can't have 1.5 CDs. And there we go. There is a pictogram, just making sure that you read a key really clearly. And of course, if you have to count how many, in this case, CDs were on a particular day, you would just label each one appropriately and add up your totals. But of course, we can't have 1.5. For a scatter graph, there's lots of things that you could be asked about. One of the things which comes up quite often, which is not on this question, is an outlier. And an outlier is a point that lies away from the rest of the points, something like this. Now when we do a scatter graph, as always, we should draw a really nice clear line of best fit, regardless of what the question is asking us to do. A line of best fit is a line that follows the general trend of the points, and ideally you want the same amount above and below. There is going to be a range of line of best fits that people are allowed, so don't worry too much about it being absolutely perfect. After all, we are not computers. Now this one says that Ellie got a mark of 34 in her science test, and it wants us to use the scatter graph to estimate how much she got on her maths mark. So if we actually have a look, the science mark is down the bottom on our x-axis, so we need to find 34, and we're going to go up from 34 up to our line of best fit using a ruler and a pencil as carefully as we can. Once we've done that, we're going to go straight over to the other axes, and you can see on this one it lands perfectly on 40. Now yours, if you were doing this, might not land perfectly on 40. It might have been just above or just below. So there are going to be a range of values that you are allowed, but for my one, we have 40. And there we go, that's using a line of best fit on a scatter graph. Now a frequency polygon is a really nice graph to draw. Part A here though asks us to find the modal class interval. Now modal class is just another word that's used for the mode when we are looking at groups. So here on the left we have categories 1 to 30 to 140, 140 to 150, and all the rest going down. So for the mode we're looking at which is the most common group.
you can see over here, there's a frequency of 24 in one of those groups. And that refers to this particular group over here. So the most common, and this is about the height of 80 children, so the most common height, or the most common group of heights, is 150 to 160, and you just copy down that inequality exactly as it's written in the table. Now this is asking us to draw a frequency polygon. When drawing a frequency polygon, just like when we were finding the mean, we actually use the midpoints. So I want to write the midpoints in. Again, you can use that same approach as before. You can add the numbers together and divide them by 2, but usually it's quite nice to spot those midpoints. From here, I just need to find the midpoints on the graph and plot them on. So 4, and then on the next midpoint we have 11. The next one is 24. The next one is 22. And then we have 19. Now with a frequency polygon, you don't connect this like we did on some of our previous graphs. It's really important with a frequency polygon that these are connected using nice straight lines, which you would use a ruler and a pencil for. So you're going to connect these together using nice straight lines, making sure it definitely doesn't look like a smooth sort of curve or sort of connected not using a straight line. There's not really a phrase that we can use for not connecting it as a straight line, but just make sure that it's really clear that you've joined that up using a straight line. You do not have to connect it to the axes or to the origin, you just need to connect it from the first dot to the last dot, just like that. Now with sampling and bias, you might be given a table that shows a particular sample. This particular question has no table. So it says Millie is planning a school trip for 240 students. She asks a sample of 40 students where they want to go, and then it goes on to tell us that 5 students choose to go to a theme park. Work out how many of the 240 students you think will want to go to a theme park. Now when we're looking at a sample, we just need to know how many chose a particular option, in this case the theme park, and how big was the sample. And we'll write that as a fraction. So in this case, that's 5 out of 40 students wanted to go to the theme park, which means that 5/40ths, or for every 40, 5 want to go to the theme park. Now you can simplify this fraction. Remember, if you type a fraction into your calculator, it will simplify it for you. So if you just type 5/40 in, it simplifies down to 1/8, which means that 1/8 of the students want to go to the theme park. So actually all we need to do is work out 1/8 of 240, which is just dividing by 8. So 240 divided by 8, we can type that into the calculator as well, and 240 divided by 8 is equal to 30 students. And there we go, 30 students want to go to the theme park. Okay, so looking at some pie charts, we have a slightly different question to normal here. Rather than drawing a pie chart, we're looking at interpreting a pie chart. Now it says here the pie chart shows the information about the favourite animal of each student at school A and for each student at school B. It then tells us there are 480 students at school A and 760 students at school B. It says Tamia says the same number of students at each school have tigers as their favourite. Is Tamia correct? Well, in order to find how many people actually like the tigers the most, we just want to break down the pie chart and see what 1 degree represents in each pie chart. We can then find out what any amount of degrees represent. So if this pie chart over here on the left, school A is 480 students, and of course 760 on the right, we want to find out exactly how much is in each sector. So if we divide each of these by 360, and we'll start with school A, 480 divided by 360 is 4/3. Not the nicest of numbers, but 1 degree is equal to 4/3. That's fine, I'll just leave it as a fraction for the moment. We can now multiply that by 60, and that will tell us the amount here that liked monkeys the most. So if we times by 60, that is 80 people. So 4/3 times 60 gives us that 60 degrees is 80. So 80 people like monkeys the most. Now there are 480 people in total at this school, and 480 take away 80 is 400. Now both the lions and the tigers here are both X, which means that they're both the same.
So if there are 400 in total, if we divide this by 2, that tells us that each of those represents 200 people. So the lions is 200 people and the tigers is 200. We now know how many people preferred tigers at school A. So we're just going to have a look at school B. Now, as it turns out, in school B, this is actually a 90-degree angle. And a 90-degree angle is a very nice one because that's 1/4 of the circle. So we could actually just divide by 4 to see that amount of people in that particular sector. However, we can take the same approach. You could do 760 divided by 360 to find out what that represents. But as it's 90 degrees, we should always look for ways of saving time. So we can actually just do 760 divided by 4, which is 1/4. And if we type that in on our calculator, we get 190. So that's 190 in this particular pie chart. We don't need to find the other two because we are only comparing the tigers. So here it says, is Tamia correct? She said the same number of students at each school have tigers as their favourite, but we've just identified that school A was 200 and school B was 190. So we would say no, Tamia is not correct. There we go. So Tamia is not correct. And we have our numbers to back that up. You could write in a little sentence, tigers are 200 at school A and it's 190 at school B. Okay, so looking at some proportion. It says here Alfie's going to make some concrete and this is how much cement, sand and stone he's going to use. It says the cement and stone are sold in bags and this is what he already has. So he has 10 bags of cement, 20 bags of sand, 20 bags of stone. Work out what bags he needs to buy to make the concrete. Well, first of all, we want to know how much he actually has. We know how much he has in bags. So he has, and if we label this underneath, we've got 10 bags of cement, 20 bags of sand, and 20 bags of stone. Well, in terms of total kilograms, because that's what we know up here is our sort of recipe for this concrete, how much we actually need. Well, 25 times 10 is 250 kilograms. Does he have enough of that? Well, he only needs 180, so we have enough cement. On to the next one. 22.5 times 20 is 450 kilograms of sand. We have enough of that. And on to the last one. 50 kilograms times 20 is 1,000 kilograms. Now, he needs 1,080 kilograms, so here is the limiting amount, and he's going to need to buy more bags of stone. So to write out exactly how much we need, 1,080, subtract the 1,000 that we have, leaves us with 80 kilograms of stone that we need to buy. Now, having a look, we can see over in our table that one bag of stone is 50 kilograms. So one bag is not going to be enough. We'd have to buy 2 bags. Yes, we'd have 100 kilograms and we only need 80, but we'd have to buy 2 bags of stone. So here we would need to buy 2 bags of stone. So there we go. 2 bags of stone would be our final answer, and that would give us enough in order to use this recipe to make the concrete. Now, these questions where we are converting both currency and units are always questions that just don't look very nice to answer. There's a lot of numbers going on. We've got one thing in euros, one thing in pounds, one in litres, one in gallons. But ultimately, all we need to do is get everything into the same currency so that we can make a comparison in terms of the value. And we also need both of them to be in the same units. Now, it makes sense to convert the currency into pounds, as that's the home currency of what we are using. So here, we're going to first change the 54 euros into pounds. Now, you can see in the pounds to euros conversion here that the pound number, the size of the number, is smaller than the euro number. They have the same value, but it's a smaller number. So in order to get the 54 euros to become pounds, we either need to multiply or divide by 0.85. But having an awareness that the number has to be smaller means that at least if we do the incorrect one, then we're going to know about it. So the correct method here is to do 54 multiplied by 0.85. That gives us that smaller number, which we'll see now. and we get £49, £45 and 90 pence. So that is the cost of the 36 litres. Now it doesn't really matter whether we make a comparison in litres or in gallons, but I can straight away find a value now for this petrol. So here it's £45.90 for 36, and I'll just put L for litres. Now we don't want to compare the price at 36 litres, we want to know what the value of 1 litre is. So to get there, we just divide by 36. So £45.90 on the calculator, divide by 36, it is 1.275, or £1.27 and a little bit extra. I'll leave the 5 in there just in case our next one comes out as £1.27 with a little bit extra as well, just in case they're really close. So for the next one, it's already in pounds. We have £81.60 for, at the moment, 16 gallons. Now it tells us here that each gallon is 4.5 litres. So I can actually turn this into litres relatively easily. I just need to do 16 multiplied by 4.5, and that's going to give it me in litres, as every 1 gallon is 4.5 litres. So 16 times 4.5 is 72 litres, and now we have a comparable sort of unit. So we have £81.60 for 72 litres, and again we don't want to compare the value of 72 litres, so we could divide by 72, and £81.60 on the calculator divided by 72 comes out as £1.13. There is a recurring dot above the 3. It doesn't really matter if we put that in, because ultimately we can see that this one is cheaper. Per litre it's £1.13 rather than £1.27, regardless of those sort of sub pennies after that. So there we go, it is cheaper in that second option, and that was in Scotland. Now it said here Olivia thinks that petrol is cheaper in France than in Scotland, but we've just showed that it's actually cheaper in Scotland. So is Olivia correct? We would just say no, Olivia is not correct. And we have all of our working out to back that up. You could write after that actually it is cheaper in Scotland. And there we go, that is some currency conversions, but also dealing with different units. When looking at a conversion graph, the obvious conversions here could be absolutely anything. This one is about hours worked and pay, so it's not really a conversion graph here. This is more of a real life graph, but it's going to be treated in exactly the same way as a conversion graph. So we just looked at some currency conversions, so this is just something a little bit different. You might have a conversion graph where on the left or the y-axis you have pounds, and on the x-axis maybe we have euros. We're going to treat it in exactly the same way. So this is more of a real life graph where it's showing how much pay you get for a certain amount of hours. It says here, how much is Jack paid for each hour that he works? Now it doesn't really matter exactly where we go up from, but I would have a look on the left of the axes there to see if any of the 1, 2, 3, 4 or 5 hours lands on a nice number. Now I've just spotted as I go up from 1, that doesn't really land on the nicest of numbers. Now you might argue that that's quite clearly in the middle, but actually going up from 2 lands on a really nice whole number there. It lands on 30. So it doesn't really matter which one you use, but we do get therefore £15 for 1 hour. So our final answer is £15. If you went for the 2 hours though, you could divide £30 by 2, again, which would get you to 15. Part B here says last week Jack worked for 36 hours. How much was Jack paid? Now, unfortunately, we don't have a number on the graph here, which is 36, so we can't read it straight off the graph. However, we can use any of the numbers to actually get to 36. Now, as we know he was paid £15 for 1 hour, we could actually just multiply that by 36. But we could take any approach. We could go across from the 2, which was £30, and times that by 18. 2 times 18 being 36. We could get the 3 hours and times it by 12. We could get the 4 hours and times it by 9. There's lots of different ways of doing this. As we've got the 1 hour and it was easy to read, it makes sense to just do £15 multiplied by 36. So on the calculator, 15 times 36, that gives us £540. So Jack was paid £540 for his 36 hours. Now in this question, we are looking at some simple interest. It says here, Ryan invests £1,000 for 5 years in a savings account. By the end of the 5 years, he had received a total of £125 simple interest. Work out the annual rate of simple interest. Now, in a question like this, simple interest is the nice one. It means that you only get the same amount of interest every single year. So if something is simple interest and it's 5 years, it means that this amount of interest here is just 5 times each amount he got each year. So I can just do 125 divided by 5, and that comes out as £25. So each year, and I can put per year after that, he got £25. And it wants to know what that is as an annual rate of interest. Well, if you put £1,000 into account, there's a few ways that we could work out exactly what that is as a percentage. Now, it's more of a non-calculator approach, but we could just think about some different percentages, which I do quite like as a method, even with a calculator. 10% would be £100. 5%, because we need to go smaller, would be £50. We're getting pretty close, and you can probably see the link now that if we halve that again, which would give us 2.5%, that is equal to £25. So actually, the annual rate of interest is 2.5%. So that's one method that you could use. You could also write it as a fraction. So what is 25 out of 1,000? That'll give us it as a decimal. If it's going to give it us as a decimal, you just need to times by 100. So when you do that, you'll see it just straight away comes out as 2.5%. That is a slightly more advanced method, knowing how to use it as obviously with a calculator method there, but that is how you find a percentage. 25 out of 1,000. It's a good one to think about if you've ever given yourself a percentage on a test. You'll know that you write your score out of the total and then times it by 100. Now our next question is looking at compound interest, and compound interest is a little bit more complicated. However, we can use the calculator really effectively for this. So it says Emily wants to invest £25,000 for 3 years in a bank. In the personal bank, she gets compound interest of 2% per year, and in secure bank, she gets 4.3% in the first year, but then only gets 0.9% for each additional year. Which bank will give Emily the most interest at the end of 3 years? Now, when you are dealing with compound interest, all we need to do is figure out the multiplier that we need. Now, to figure out the multiplier, essentially, we add the percentage that we've been given to 100%. So 100 plus 2 means that each year it's 102%. Now, as a multiplier, all we have to do is turn that into the decimal version, which is just dividing by 100. So it's 1.02. And that's what we have to multiply by to increase by 2%. So in this question here, for personal bank, we start with £25,000. We have to multiply by 1.02. And that will do 1 year. From there, you could write it down and then multiply by 1.02 again to find year 2, write it down, and multiply by 1.02 again, and write it down, and you'll have your 3rd year. However, you can get around that by just doing the power for the amount of years, and that'll just multiply by 1.02 3 times and do it all for you in one jump. So 25,000 times 1.02 to the power of 3, that comes out as £26,530 and 20 pence. So that's how much she'll get if she invests in personal bank. Now we do need to be a little bit more careful with secure bank because there is a different amount in the first year. And with 4.3%, we do get some quite small percentages in terms of the multiplier. So if we add that to 100%, in this question, you would get 104.3% in the first year. To turn it into a multiplier, divide by 100, and just being really careful of those decimal places, we get 1.043. So in the first year, we need to times by 1.043. So 25,000 multiplied by 1.043. I only get that in the first year, so I am going to have to write that down this time. 25,000 times 1.043 gives me £26,075. Now that is now how much Emily has in the bank. 26,000 and £75, and we're going to have to multiply that by the new multiplier for the 0.9% that you get in every extra year. So adding that to 100 wouldn't be much over, it'd be 100.9%, and that's all that we're going to get in that second and third year. Again, dividing that by 100, which is being really careful now, because we do get 1.009, and that's what we're going to have to multiply by. Now you've got two options again. You can multiply by 1.009, write it down and do it again, but I'm going to put a power of 2 with this one for the 2 additional years. So 26,075 times 1.009, and then that is to the power of 2, and that comes out as £26,546.46. So you can see here, actually, we get slightly more in the secure bank. Not much more, it's about £16.26. So we would just say here, which bank will Emily get the most interest? So we want to make sure that we write down somewhere near our working out, secure bank, and you could write some more with that. If you prefer, you could write secure bank will give Emily the most interest, but just make sure it's really nice and clear which one we're choosing. Now this next question is some direct proportion. It says Reese wants to make some orange juice and he's going to buy boxes of oranges. There are 24 oranges in each box and 30 oranges make 2 litres of orange juice. Reese needs to buy enough oranges to make 8 litres of orange juice. Work out the number of boxes of oranges that Reese needs to buy. Now if he needs to make 8 litres and 30 oranges will make 2 litres, well, how many of those 30 oranges are we going to need to buy 8 litres? Well, to get from 2 to 8 litres, that is multiplying by 4. So that would be 8 litres, and that would be 30 times 4, which is 120 oranges. So 120 oranges equals 8 litres. So we need 120 oranges. We just need to now know, if we need 120 oranges, how many of the boxes that we need to buy. Now it says that there are 24 oranges in each box. 24 oranges in each box. So if we want to know how many boxes we need, we'll divide by 24 oranges to see how many boxes we're going to need to fit into 120. 120 divided by 24 gives us 5 boxes. And there we go, 5 boxes would be our final answer, and that's just a bit of direct proportion. Now, inverse proportion in context is always one that just throws people a little bit, because it is, as the title says, the inverse, and that's the opposite of what we're used to. So here it says it would take 120 minutes to fill a swimming pool using water from 5 taps. How many minutes will it take to fill a quarter of the pool if only 3 taps are used? Now, the first thing that we need to think about is that 5 taps, it says, is equal to 120 minutes. Now, with all proportion, we tend to have to think about, well, how long would 1 tap take? Now, in this scenario, with normal proportion, you would divide by 5. However, if you think logically, that whole method doesn't make any sense. If 5 taps take 120 minutes, you can't do 120 divided by 5 for 1 tap, because that wouldn't make any sense for 1 tap to take 24 minutes if 5 taps take 120, because obviously it's going to be slower if we turn 4 of the taps off. So if we're going down to 1 tap, we actually just do the opposite of what we normally would. So here, where we're dividing by 5, on the opposite side here, we need to multiply by 5. So 120 multiplied by 5 would give us 600 minutes. So with inverse proportion, whatever we do on the left, we're going to do the opposite on the right. Now the whole point of this is we want to know what 3 taps are going to take. We'll forget about this quarter of the pool for the minute, and we'll come and deal with that after we've found out the full pool. So to get from 1 to 3, we would multiply by 3. If we've multiplied by 3 on the left, we're going to divide by 3 on the right. And that means that 3 taps is going to take 200 minutes. Now this question here doesn't want to know the full pool, it only wants to know 1/4 of the pool. So we need to find 1/4 of 200. To find a quarter, you divide by 4. So 200 divided by 4, which gives us 50 minutes. And there we go, that'll be our final answer for this one, 50 minutes. Part B here says state any assumptions you made in your working out with your answer for part A. So if we're going to state assumptions, well, we assume in this question that all of the taps run at the same rate. If the taps do not run at the same rate, then actually it could be a longer or a shorter time. So we just need to say something about the rate. So we assume all the taps, and we go run at the same rate. There we go. And if we were asked about, well, what if our assumption was wrong? Well, actually our time could be higher or lower. So looking at a distance time graph. It says here Brandon drives his car on a journey. Here is the travel graph for the first 15 minutes. Work out Brandon's speed in kilometres per hour for the first 15 minutes. Now it might be that you want to use your speed distance time formula. However, you might not necessarily need to. It's already told us that this is 15 minutes and we can see that it's between 10:10 and 10:20. So that particular journey is 15 minutes. So it's taken him 15 minutes to go 20 kilometres. Now if you wanted to, with speed distance time, you could now convert the minutes into hours by writing it as 15 over 60 and using your formula. But in this particular question, we actually just need to get to 60 minutes. We want to know a speed, and normally we would give a speed in kilometres per hour. So to get to 60 minutes, all we need to do is multiply by 4. And you can do that on your calculator. 60 divided by 15 is 4. So all we would need to do is times by 4. And that means we would go 80 kilometres in 60 minutes. And there we go. So our speed in that first 15 minutes is 80 kilometres per hour. And there we go. That'll be our final answer for part A. It says at 10:15, Brandon stops for 10 minutes. And then drives for 20 minutes at a speed of 75 kilometres per hour. On the grid, complete the travel graph for Brandon's journey. Well, if he stops for 10 minutes, well, each of these lines going across is 5, so that's 5 minutes, and then another 5 minutes. So that means we get to here. And then he drives for 20 minutes at a speed of 75 kilometres per hour. Now, it doesn't say that he drives home. It says he continues driving. So our distance time graph is going to keep going upwards. Or in other words, it's going to sort of keep going up to here somewhere. We just need to figure out exactly where it's going to go. So 20 minutes at a speed of 75 kilometres per hour. Now there are different ways that you could approach this. We could think about approaching it in terms of a formula, like we've done before. So speed, distance, time, we could use a formula triangle. If you prefer, let's have a look. And we want to know a distance. We have a time and we have a speed, and we want to know a distance. So all we have to do is multiply these two pieces together. Now the speed is 75, however, and this is why I prefer the method I used above, because now I need to multiply by 20 minutes, but it needs to be in hours. That's not difficult for us to do, it's just 20 out of 60. But in the moment of an exam, you've got to remember to do that. So it's 75 times 20 over 60. If we times by 20, hopefully it would trigger through to you there. That's far too much because 75 times 20 would give us a distance of 1,500 kilometres. And that obviously goes way off our graph. So we're doing 75 times 20 over 60. If we type that in, that comes out as 25 kilometres. So Brandon does 25 kilometres in the 20 minutes. You could think about this in lots of different ways though. That is 1/3 of an hour. So if it's 1/3 of an hour and he does 75 kilometres per hour, well, 1/3 of that is 25. So lots of different ways that you can think about these questions. So in 20 minutes, let's figure out how far along that goes. Well, each line is 5. So if we sort of imagine 1, 2, 3, 4, that gets us 20 minutes across. It just needs to go 25 kilometres up. We're currently at 20, so we need to go up to 45, which is just here. And there we go. So if we connect this up now, that's 20 minutes later. And just double check that, we're on 25, we get to 45. And therefore, there we go. That is where our graph is going to finish. So a nice straight line joining that up. And there is our distance time graph. Now, if we're dealing with speed, distance and time, and we have a calculator, of course we can use a calculator at any point. So for this, if we use a formula, and if you use a formula triangle, that's absolutely fine. So here, I'm going to do a formula triangle with speed, distance and time. If you prefer, you can write down the formula, you can rearrange it for your 3 different versions. It's absolutely fine which method you prefer at this point before the exam. So it says here, Taylor cycles a distance of 15 kilometres at an average speed of 12 kilometres per hour. She then runs a distance of 6 kilometres at an average speed of 4 kilometres per hour. Work out the total time Taylor takes and give your answer in hours and minutes. Now again, if you have non-calculator methods that you prefer, absolutely fine if you want to stick with them. But here we're going to be working out a time. So if we're working out a time, it's distance divided by speed. So here, in the first instance, let's label this number 1 for this first one, and then we'll deal with number 2. So for number 1, we have a distance of 15 and a speed of 12. And if we do 15 divided by 12, we get 1.25. And we'll come back to that in just a moment. For the second part of the journey, we have a distance of 6 and a speed of 4. And if we work that out, 6 divided by 4 gives us 1.5. Now you can add these together and then convert them into minutes, or you could write them as minutes now. Hopefully we know that 0.25 is 1/4, and that does not stand for 25 minutes, but in fact it stands for 15 minutes. So for this one, this is 1 hour and 15 minutes. If you're not sure about that, you can always times the decimal by 60. And for this one, 1.5 is an hour and a half, which is 1 hour and 30 minutes. Now together, if we add those up, which is what it wants us to do, give the total time, we get 2 hours and 45 minutes. And there we go, that is using our speed, distance, time formula, and we had 2 journeys there that were sort of being added together to get an overall total. So this next question is looking at density, mass and volume, and this one here actually gives us a prism that needs us to work out the volume of. It says the prism is made from wood with a density of 0.8 grams per centimetre cubed. Work out the mass of the prism. So our formula for density, and again you can use a formula triangle, density is equal to mass divided by volume. So here we're working out a mass. So to get a mass we do the density multiplied by the volume. We're given the density in the question, but we're not given the volume. But of course we're given the shape and it wants us to work out that volume. To get the volume of any prism, you work out the area of the cross section, which is the shape that passes all the way through the shape. In this case a triangle goes all the way through. And then we're going to times it by the length. And in this case the length is 10. So we need to know how to work out the area of a triangle, which is base times height divided by 2. So here the base is 4, the height is 6, and we're going to divide that by 2. That is equal to 12. So the area of the cross section is 12. To get the volume, you take the area of the cross section and you multiply it by the length that it goes through the shape. So 12 times 10 gives us a volume of 120 centimetres cubed. Now with all density questions, you do need to make sure before we use it in our formula that our units match. And in this question, we do have centimetre cubed in our density units there. So we already established we're going to do the density times the volume as we're working out the mass. So 0.8 being the density multiplied by 120, which is the volume that we've calculated, and 0.8 times 120 is 96. Now the units for the mass are also in the question. We're told grams here, so we know that the mass is in grams. And there we go, 96 grams is our final answer. Okay, so in this question we're looking at pressure, force and area. It says here a force of 70 newtons acts on an area of 20 centimetres squared. And we are given the pressure is equal to force divided by area formula. It says the force is increased by 10 newtons and the area is increased by 10 centimetres squared. Tau says the pressure decreases by less than 20%. Is Tau correct? Well, let's have a look. So if we start off by using our initial numbers, we have a force of 70 and an area of 20. And we can type that in on our calculator. 70 divided by 20 gives us 3.5. So there we go, that's our initial amount. Now in the second amount, it says the force is increased by 10 newtons. So we have 80 newtons now on the top. The area is increased by 10. So that would be 30 centimetres squared. And we can work that out. So 80 divided by 30. Again on the calculator, we do get a recurring decimal for this one. It comes out as 2.6 recurring. So these are our two values. It says, Tau says the pressure decreases by less than 20%. So let's just have a look. Decreases by less than 20%. So if we work out 10% of the pressure up here, 3.5, and then double that, or just work out 20%, and subtract that from 3.5, we can compare it to this 2.6 recurring, and then we'll decide if it's more or less. Now with a calculator, you can of course just work out 1%. I'm going to work out 10%. So 10% is 0.35. 20% will be double that, 0.7. So 20% is 0.7. Now if we do 3.5, subtract 0.7, and again we could just do this on a calculator just to make sure we get everything correct, that comes out as 2.8. So clearly they are different right now. So the pressure decreases by less than 20%. Well, if we decrease it by 20%, it goes down to 2.8. This has gone down to less than 2.8. It's gone all the way down to 2.6 recurring. So actually, no, tau was wrong. It decreases by more than 20%. So is tau correct? No. You could say it decreases by more than 20%. There you go, by more than 20%. We don't need to say what the exact percentage is. It doesn't ask us that, it just says is he correct or not. We've done the working out, we've shown that it decreases by more than 20%, so it's fine just to make that statement at the end. Okay, so for sharing in a ratio. This question says Alex, Priya and Jordan share some money in the ratio 3:4:2 and Priya gets £120. Now to be fair, before we even carry on, we could work out now how much everybody else gets, because the money that Priya gets is going to go underneath the 4. So that's going to be 120. Now we'll carry on reading through the question, but we're going to need to come back to that. So it says Alex then gives some of his share to Priya and some to Jordan, and the money they now have is in the ratio 2:5:3. How much money did Alex give to Jordan? So Jordan is the number at the end, so we'll figure out how much money they actually shared. We'll split it back up into this new ratio and we'll see how much he actually gave to Jordan. So here we know to get from 4 to 120, we need to figure out what to divide by, or what we've multiplied by. So we can divide 120 by 4, which is 30. So all of these are getting multiplied by 30. So the 2 becomes 60, the 3 becomes 90. So we can now go ahead and add these together. So 90 plus 120 plus 60, and that adds up to 270. And in this particular scenario, Jordan had £60 and Alex had £90. So when we look at how much money did Alex give to Jordan, we want to look at how those numbers changed. So in the new ratio, we have £270, and that's getting split up in the ratio 2:5:3. Now in total, there are 10 parts. So 270 divided by 10 is equal to 27. So we want to multiply all of these numbers by 27. So 27 times 2 gives us 54. 27 times 5 gives us 135. And 27 times 3 gives us 81. So we're going to look in at either how much money Alex gave away to the other two and do them separately, or for this one, as we want to know how much money Jordan was given, we can just have a look at how much money Jordan went up to. So Jordan went from 60 down to 81, so our total there would be 81 minus 60, and that is equal to £21. So obviously a question like this, where you have two separate ratios, but it is just sharing in a ratio. But we had a whole story going on, and in this particular example, we had this scenario where we were told one of the numbers in the ratio. So Priya was equal to 120. But of course, you could be told the total, you could be told the difference between two of them originally. And all of those, you just need to be careful with the language in terms of how to approach it. But there we go, that was a question on sharing in a ratio. Okay, so in this question we have some angles involved, but we also have some ratios involved within these angles. So this particular one focuses on a triangle, but of course this could be involved in any type of shape. Now we know that a triangle, the angles add up to 180 degrees. Now here we actually have sort of two triangles that have been put together, but we have this large triangle around the outside and we are missing that bottom right angle. But it tells us in the question that the size of angle DCB, which is this one here, to the size of angle ACD, this little one here, is in the ratio 2:1. Now that could be written as algebra. You could write it as 2x and 1x, however you prefer to look at it. Or of course we could figure out what angle we are missing and just share it in a ratio like we normally would. So this is a relatively nice one in the sense that we can just add together the 51 and the 75, which gives us the total of the angles within the triangle that's given to us currently. So that's 126. We can then take that away from 180. So 180 minus 126, obviously showing all of our working out, is equal to 54. So we can now share that in the ratio 2:1. Or I could treat it with algebra, which I'd do in the same way. We'd have 3x is equal to 54, and we divide by 3 just like we would if we were sharing in a ratio. So 54 divided by 3 gives us that x is equal to 18. We now just need to apply that to the correct angle. So BDC is the angle that we're looking for. Well, this angle here is 18, 2x just below is 36, and now we can actually look for the angle BDC. So BDC is within this sort of secondary smaller triangle down below. And BDC is the angle in the top there. So now we know the two angles in the smaller triangle. We have 51, add the 36. In total, that gives us 87. And we want to take that again away from 180 to find that missing angle within the triangle. So 180 minus 87 leaves us with a 93 degree angle that's missing at the top there. So there we go, that is a slightly harder problem degrees. Here, as we have a right angled triangle connected to a circle sector. It's a relatively nice circle sector because you can see we do have a right angle here, which I'll label, which means it's 1/4 of a circle. So nice circle sector. It says the right angled triangle, ABC, has an angle of 90, which we can see there, 90 here as well. And the quarter circle has centre C and radius CB. Work out the area of the quarter circle and give your answer to 3 significant figures. Now, in order to work out the area of any circle or circle sector, we need to know the radius. And the radius here is connected in between the sector and the triangle. So, although we've already looked at this topic, this is actually involving Pythagoras. And it's another Pythagoras question where we're looking for the shorter side. So with Pythagoras, we're going to square both the sides. When finding a shorter side, we subtract them. So 9 squared take away 6 squared. We can write that down to start with. We then have to square root our answer. So that does come out as 45. To get that length, we need to square root 45. And if we do the square root of 45, we do get a decimal here, although it did say to give your answer to 3 significant figures. So we know there's going to be decimals involved. 6.708203. There are a few more decimals and feel free to write them all down. However, I have written down 7 significant figures there, so I shouldn't have any rounding errors as I've gone way beyond 3. Now, we need to know how to work out the area of the circle sector. So when working out the area of a circle, we have our formula. The area of a circle is equal to pi r squared. Well, we now know the radius. This is r. So this is our radius here. So we just need to put that into our formula. So for the area, we'll do pi multiplied by that number there squared. I'll put it in brackets as it's quite a long number. That squared's going to look a little bit strange at the end of it. So 708,203 squared, and we'll work that out. I'm going to use the full number as it's still on my calculator, but it would be absolutely fine just to use that rounded version in this question. Now that comes out as 45 pi, or as a decimal, 141.3716694. Now, as it is a quarter circle and not a full circle, we do need to account for that. So for a quarter circle, we would just divide by 4. And if we divide this answer by 4, that will give us the area of the quarter circle. So dividing that by 4, and I'll have to write it over here, we get 35.34291735. It wants the answer to 3 significant figures, so I will chop it after that third number there, and that is 35.3. And don't forget, this is an area, it's in metres, so it would be metres squared. Of course, the dotted line on your exam might say metre squared on it, but do check. If it doesn't, you are going to get a mark for writing the correct units. But there we go, there was a question looking at Pythagoras to find the radius, and then using area of a circle with a circle sector as well, so having to divide our answer by 4. Now this question here looks way more complicated than it actually is. It is a tricky question, but it definitely looks more complicated than it actually is. And that's because of this bit down here. It says show that x is equal to the square root of k pi, where k is an integer. Now let's just see what we can do, and you'll see that actually this isn't too bad. It says the diagram shows a cube with edges of length x and a sphere of radius 3, and it gives us the formula for the surface area of a sphere. The surface area of the cube is equal to the surface area of the sphere, and then it wants us to show that. Well, where it says the surface area is equal to, that means if we get the surface area of the cube, we'll just put an equal sign and then put the surface area of the sphere. Now the cube, of course, has algebra on there, so it is a tricky one to get the surface area of. But in this question here, there's a really easy mark just for getting the surface area of the sphere. So all we have to do is put 3 into that formula. So over here, if we put 3 into the formula, we get 4 times pi, just using this formula here, times the radius squared, so times 3 squared. And of course, that's just typing it into a calculator. In fact, you don't even need to type this into a calculator because that's 4 times 9. Remember, 3 squared is just 9. 4 times 9 is 36, so you can just leave it as 36 pi. And actually, the question does want a pi symbol in the answer. So actually there's a big hint there that we don't even need to type this into a calculator. But 4 times 3 squared is 36. That's part of it done. Now the cube has side length of x, and all of the sides are equal to x. Now if you want to work out the area of just one face, let's just look at this one on the top, and that is a square with side lengths of x. Well, that face would just be x squared. X times x is x squared, and that's the area of the face. Now a cube has 6 faces. So if one face is 1x squared, then all 6 faces would be 6x squared. And that is the surface area of the cube. There we go, just taking our x squared and multiplying it by 6. So we now have the surface area of the cube, 6x squared, and the surface area of the sphere, 36 pi. And it wants it to say x equals. So actually the first thing that we need to do is actually just sort of solve this as if it was an equation. That kind of is an equation, it's just that we have a pi symbol there. So to start with, we want to divide by 6. Just like we would if it was 6x equals 36, we would just divide by 6. When we do that, we get x squared is equal to 36 divided by 6 is 6, so 6 pi. And you can probably see that we're basically done now. To get rid of the squared, we're going to need to square root, and we'll square root the other side, and we get x is equal to the square root of 6 pi. And there we go, we've got our final answer. X is equal to the square root of 6 pi. So there we go, k is equal to 6. It doesn't ask us to say what k is equal to, just wanted us to show that x was equal to the square root of something pi. We found that it was 6 pi. And there we go, there's our final answer. Definitely a tricky question, but not as bad as it looks. Now, when we are looking at similar shapes, when you see that word similar, it means that one shape is an enlargement of the other. Now here, both of the shapes are drawn in the same orientation, and you can see that via these little bits that are labelled on the angles. It tells us that's the same angle as on the other diagram. So before we even think about how to find any missing lengths, we need to identify what the scale factor is between them, which means we need to identify a similar side on both, or the same side on both, that has actually been given. So you can see on the left we've been given 8.4, and in the same position on the right we've been given 12.6. So to find what it's been multiplied by, we just need to do the bigger length, 12.6, divided by the corresponding smaller length, 8.4. That's going to give us the scale factor. So 12.6 divided by 8.4 comes out as 1.5. Now that is our scale factor. That means to get to the right triangle, the bigger triangle, we would multiply by 1.5. And to get to the smaller triangle, we have to divide by 1.5. So now we're just going to apply that. Work out the length of DF. Well, that's going from the smaller triangle up to the big one just here. To do that, we would do 6.4 multiplied by 1.5. And just make sure you use your calculator to get this right. And that comes out as 9.6. So there we go. That would be 9.6 centimetres. For the other part of the triangle, it says work out the length of C to B. Now that is going from the 15 back to the smaller triangle. So we would divide by 1.5. And we're doing 15 divided by 1.5. 15 divided by 1.5 is 10. So our answer for that would be 10 centimetres. So there we go. Regardless of the diagram, do the bigger shape divided by the smaller shape. And just make sure you match up that corresponding length. And if you are given the diagram, and the diagram is drawn inside of one another, in this sense here, so if we have the larger triangle on the outside, and they draw the smaller triangle on the inside, which this one could have been drawn like this, something like that, then just remember to split those shapes up and draw them separately, like they've done in this diagram. But there we go, that's some similar shapes. Okay, so this question is looking at a cylinder. It says here, Karina has 4 tanks on her tractor. Each tank is a cylinder with diameter 80 and height 160. The 4 tanks are going to be filled completely with a mixture of fertiliser and water. The fertiliser has to be mixed with water in the ratio 1 to 100 by volume. Karina has 32 litres of fertiliser. And it tells us here that 1 litre is equal to 1,000 centimetre cubed. Has Karina enough fertiliser for the 4 tanks? You must show how you get your answer. Well, for starters, we need to actually work out the volume of one of these cylinders. So the volume of a cylinder is the same as any other prism. You get the area of the cross-section and times it by the height. Now the area of the cross-section here is a circle. So we need to get the area of this circle. To do that, we want to know what the radius is. The radius is half of the diameter, so that's going to be 40 centimetres. And then we're going to use our formula, pi r squared. Once we've done that, we'll times it by the height, and that's the volume of the cylinder. So if we work that out, that's going to be pi times 40 squared, and we can either type that in and then times by 160, or we can just times by 160 straight away. And let's just write that down then. So pi times 40 squared times 160, and that gives us a very large volume here, but we get 804,247.7193. And there we go, that is the volume of one tank, 804,247.7193 centimetres cubed. Now it says here that we are going to have 4 tanks. Well, she has 4 tanks. So we need to multiply this by 4. That's going to give us the volume of all 4. So if we press times 4 on the calculator, we're starting to get to some very large numbers now. That's absolutely fine though, just make sure we write them all down. So we have 321,690.877. So that's 3.2 million centimetre cubed. Right, so we're getting some very large numbers. Now, it says here, Karina has 32 litres of fertiliser, and it's going to be mixed in the ratio with water 1 to 100. So we're going to need to work out exactly how much volume we have here, but that's given to us in litres, and we're currently working in centimetre cubed. So completely up to you. You could either convert the 32 litres into centimetre cubed and keep dealing with very large numbers, or we could turn this volume now into litres, and we can do that just by dividing by 1,000, as it's 1 litre for 1,000 centimetre cubed. So if we divide that by 1,000, at least we're going to get some slightly smaller numbers. So here in litres now, the 4 tanks is 3,216.990877, and that's now in litres. So that's how much space is in those 4 tanks. We just now need to work out exactly how much space we actually need. So the fertiliser is to be mixed with water in the ratio 1 to 100. So the fertiliser to the water is 1 to 100. Karina has 32 litres of fertiliser. So she has 32 litres, so we need to multiply by 32, which means we're going to have 3,200 litres of water. And the total there, if we add those two together, is 3,232 litres. So, has Karina enough fertiliser for the 4 tanks? Well, it does say the 4 tanks are to be filled completely with the mixture, so they have to be completely full. Well, Karina has 3,232 litres, and space-wise, she has 3,216 litres. So she has more fertiliser than she needs to fill the tanks. Only a little bit extra, but that does mean, yes, she is going to be able to fill the tanks. So we would say yes, and you could write next to that, she will be able to fill the tanks. You can write any sort of explanation you want with it, because she has 3,232 litres and the tanks are only 3,216. So she is going to be able to fill them. And there we go. That was a functional volume question dealing with cylinders and having a little bit of ratios in there.
Okay, so looking at a Venn diagram. Now here we have the universal set, and it says the numbers 1 through to 10. So they are the only numbers that we're allowed to put in the Venn diagram, and all of those numbers have to go somewhere in the Venn diagram, whether it's in A, B, the intersection, or around the outside. So it says in A we're going to have odd numbers, and in B we're going to have square numbers. So if we write down the odd numbers that are in the list there, we have 1, 3, 5, 7 and 9. And the square numbers within the list, we have 1, which is 1 times 1, 2 times 2 is 4, and 3 times 3 is 9. So there we go, they are the square numbers that are within that list, of course. 4 squared is 16, so it's outside the list, so just the 1, the 4 and the 9. Now the first thing we want to do is have a look if there's anything in both. So we have a 1 and we have a 9. So they're going to go in the intersection. Now as soon as I put them in the Venn diagram, I'm going to cross them off my list. I then have 4 that goes in B, and we'll cross that off. And I have 3, 5 and 7 that go in A. So 3, 5 and 7. So you can see there we have some remaining numbers. We have 2, we have 8 and we have 10. And let's cross those off. 2, 8 and 10. And you can see there I didn't cross off the 6. So I've got 6 as well. So always make sure you cross them off just to make sure you don't miss a number. Now I've got a couple of questions about this. So the first one, it says a number is chosen at random from the universal set. So out of all of these 10 numbers, find the probability that it's in set A, N, B. And that little n stands for the intersection. So when looking at the intersection, we're looking at the numbers here that are just in this crossover part called the intersection. So there are 2 numbers. So we would write this as a fraction and just say how many it's out of. So count up how many there are. There should be 10. This is a good opportunity now to count to make sure we do have 10. So 1, 2, 3, 4 on the outside, 5, 6, 7, 8, 9 and 10. So 2 out of 10. You don't need to simplify that. You can if you want, but just make sure you don't simplify it incorrectly. You could also be asked about the union. So instead of an n, you'd have a u. If it refers to the union, it's looking at all the numbers in the middle and in A and B alone. Okay, so part B here, or part C now, it says find the probability this number is in set B dash. Now the little dash there means not in B. So not in B means it can't be, let's use a different colour here, it can't be 4 because that's in B, and it can't be 1 and 9. Even though they are in A, they are also in B. So not in B means it can't be either of those positions. So in terms of the numbers it can be these 3 here, and it can be these 4 here. So 3 plus 4, that gives us 7, and again that's out of 10. So there we go, that is looking at Venn diagrams and
so in this
also
question,
some set
we
theory.
obviously have a two-way table, but there isn't a two-way table drawn. We just have a lot of information. There are 800 students at a school. They either have school dinner or a packed lunch. 31% have packed lunch, 55% are boys, 60% have school dinners. How many girls have packed lunches? And you must show you're working. Now, whenever we have loads of information like this, we just need to think about trying to draw a two-way table, particularly when it splits things up like this into school dinners and packed dinners, and then gives us a secondary piece of information. And that's why we have a two-way table, because we've got these two different things. We have whether they have a certain lunch, and then when we have whether they are boys or girls. So here we're going to go for the school lunch, we're going to have the packed lunch, and we're going to have a total. We are then going to have the boys, the girls, and again a total. And all we're going to do is try and fill in all these boxes. Ultimately, it wants to know how many girls have packed lunch, which is this box here. So our goal is to find the number that goes in that box. So here there are 800 students in total. So 800 would go into our total in the bottom right. 31% of them have packed lunches. So we need to work out 31% of 800. Now, whenever I'm using a calculator, I'll always go for 1%. So I'll divide by 100, which will give me 1%. So 1% is equal to 8. We want 31%. So I'm going to times by 31. That'll tell me how many have packed lunches. And I'll do that on the calculator, and that comes out as 248. So there are 248 students here that have packed lunch. I'm going to tick that off because we're done with that, and we're done with the 800. I can now find the school lunches because I can do 800 subtract 248, which gives me 552. And typically each piece of information that we put in will give us at least one more. Now the next one, 55% of the students are boys. So I can figure out how many boys there are. I know 1% is 8, so if 1% is 8, I can do 55%, so 8 times 55, and that gives me 440 boys. There you go, 440. I can now work out how many girls there are. 800 take away 440 gives me 360 girls. That's that line done with. We're getting pretty close to that box. 60% of the boys have school dinners. So I labelled it as school lunches, but there we go, school dinners. So for the boys, 60% of the boys. So you've got to be careful here because it's no longer out of 800, there are 440 boys. So for this box here, we're going to have to be extra careful. There are 440 boys, so 1% dividing that by 100 would be 4.4, and 60% of them have the school dinner. So 4.4 times 60 gives us 264. So there we go, 264 go into this box. We can now work out how many girls had the school dinners, because there was 552 students that had school dinners. 264 of them are boys, so that means 288 of them were girls. We can now go straight across. We actually don't need to find the packed lunch for the boys. You can do if you want. It doesn't say that we had to sort of complete a table. We just need to find that highlighted box there. So 360, take away the 288. That's the total girls. Take away the girls that had school dinners. And that leaves us with 72. And there we go. That is our final answer, 72. And using the two-way table is showing our working. I have had to show around the side the percentages that I've done. I think that was sort of sensible to write those in anyway, because we're obviously going to get working out marks in this question. But there we go, we could actually work out the boys that had packed lunch, even though it's not needed. 248 divided by 72, and that gives us 176. And I do like completing that last box, because I can now check just to make sure that they add up to 440, just to make sure I have done my table correctly, and they do. So there we go, I'm happy that my table is complete. And there we go, there's a two-way table. When we're looking at a probability tree, just like when we had to know that the probabilities in a table added up to 1, here the probabilities on each pair of branches add up to 1. So that's the information that we need in order to complete a probability tree. And this one does want us to complete this tree. We don't really need to know about the context just yet. All we need to do is complete it. So to work out the bottom of that branch, we need to do 1 take away 0.13, and that gives us 0.87. And again, use your calculator for these. Don't sort of guess the answers or just speed through them. Just make sure you do type it into your calculator and get them right. So there's that one done. On to the next pair of branches. We have 0.06, and we need our other branch here. So again, I'm going to do 1 subtract 0.06 on the calculator. Take away 0.06 leaves us with 0.94. So there we go. Again, not rushing it, just type it into the calculator, making sure I get that number correct. Now the branches below are exactly the same, so this is 0.94 as well. So there we go. It's always nice when both those branches are the same, just speeds up that process a little bit. Now it says here, for a day that Morgan goes to work out the probability that the train to work and the train home will both arrive late. Now it's quite common on these questions that the route that it's asking for were already given to you. Just allows you to at least answer part B if you can't do part A. So here we are given those two, and all you need to do is multiply the two decimals or fractions, if it's fractions, together. So here, and we're going to write that calculation down, 0.13 multiplied by 0.06. I'm just going to type that into the calculator, double check that we've typed it all in correctly, and there we go, we get a final answer here, and mine actually comes out, and yours might not, but mine has actually come out in standard form. I've got my calculator set up so smaller decimals are given to me in standard form, but actually it comes out for me as 39 over 5,000. Now it's also come out as 7.8 times 10 to the negative 3, which I could convert back. This just so happens that my calculator has done this, so I could go back 1, 2, 3. There we go. I could write it as a decimal if you prefer, if you don't like the look of a sort of fraction or a standard form number here, but actually it would be fine for me to give my answer as the fraction 39 over 5,000. It's just that typically when doing these questions you wouldn't see your answer written like that. But there we go, 0.0078 is the decimal version. I'll write that down here as well, 0.0078, or of course, as I said, you can write that as a fraction. But there we go, there is our final answer for the probability tree. Okay, I'm looking at a frequency tree. Now it says here 200 people live in a village, that's given to us on the frequency tree, and then starts to tell us a lot of information. So I'm going to start to fill these in as I read it. So 23, this is already done, 23 people do not have a garden, so that's 23 here. Straight away I can do 200 take away 23 and get the 177 people that do have a garden, and I'll tick that off. 10 males do not have a garden, so I'm looking at the do not have a garden route, and there are 10 males. I can tick that off. 23 take away 10 leaves us with 13. That now adds up to 23 on the do not have a garden route. It says 95 people are male. So this one here doesn't give me a number to put in straight away, but it does tell me that these two circles here that have the males in have to add up to 95. Well, I have 10 in that top circle, so this one has to be 85. And there we go, we've done with that. There's 177 people that do have a garden. 85 of them are males, so if we take away the 85, that leaves us with 92 in the female circle. And there we go, we've completed the frequency tree. Now it says one of the people who does not have a garden is chosen at random. Now this is really important because it says one of the people who does not have a garden is chosen. So we're only looking at the people who do not have a garden. So it's out of these 23 people. Write down the probability this person is a female. Well, there are 13 females, and we're only picking out of those 23, so that's 13 out of 23. You've got to be really careful on these questions to read the language. If it just said one of the people is chosen, then it would have been out of 200. But it specifically says one of the people who does not have a garden is chosen. So it was just out of those 23. And there we go. You can leave your answer as a fraction. You don't need to simplify it if it did simplify. And there we go. There's our final answer for the frequency tree. Okay, and onto a plan and elevation. It says here is a solid made from a square base pyramid and a cube. Each edge of the solid has length 6 centimetres. So looking at the cube, that means this is 6, this is 6, we've got 6s everywhere. It says on the centimetre grid, draw the plan of the solid. Now the plan is from above. Now when you're drawing a plan from above, you can, if it's difficult to visualise the top from above, you can always have a look at this base. And the base here is a 6 by 6 square. And that's essentially what we're going to see from the top. So all I need to do, and make sure you leave enough space to actually do 6 by 6, I'll do the length of 6 to start with, and then the length along the bottom of 6 as well, and double check and count them, make sure you've actually done 6. And there we go, I'm going to join it all up from above. And my line there has just gone slightly under. I probably would redraw that, but there we go. There's 6 by 6. Now, any edge that you can see, you should also draw in. So here you can see at the top of this pyramid here, there are 4 edges running down to each corner. And we would see those from above. So in terms of the central point in the middle of the square here, we would also have 4 lines going off to each corner that we would see, which is those sloped lines going down from the centre. And there we go, there is our plan and elevation.
And looking at circumference of a circle, here it says a farmer has a field in the shape of a semicircle of diameter 50. The farmer asks Jim to build a fence around the edge of the field, and Jim tells him it will cost £29.86 per metre of fence plus £180 for each day's work. Jim takes 3 days to build the fence. Work out the total cost. Well, the easy bit that we can work out here is the £80 each day that he does. So we can do 3 times 180, and that will tell us how much we have to pay him for the actual process. So that costs £540. Now we need to actually work out the cost of the fence. So this particular question is about the distance around the outside. So we're going to look at the circumference formula, which is circumference is equal to pi times diameter, or pi times 2r, depending on which formula you like. So for this one here, we have a diameter of 50, so we can do pi times 50. We'll obviously type that into our calculator, and that comes out as 157.079, and a few more decimals there. Now that would be if it was a full circle. So this particular question is a semicircle, so we're going to need to divide that by 2, and that's going to tell us the curved part, which I'll highlight in just a moment. That comes out as 78.539. Now that is just the curved part here for the semicircle, half of the circumference. We also have to add on this additional 50 metres, so we're going to need to add 50 to our answer to get the total distance around this field. So add 50 and we get an answer of 128.539 and a few more decimals. Now it doesn't really say in this question as to whether we could buy part of a metre. So for this one, we would round this up to 129 metres. So we're going to need 129 metres. It costs £29.86 per metre, so we'll times that by the 29.86 pence. So if we do 129 times £29.86, that comes out as £3,851.94. And that is the cost for the fence. Now, of course, the total cost will be the cost of the actual fence plus the cost for the work for each day, and that's 3 days of work. So we need to add those two together. So we'll add £540 to our answer, and that gives us a total cost here and a final answer of £4,391.94. So there we go, that is our final answer for that one, and of course that was looking at circumference of a circle. Just remember, of course, if you were looking at something like the area of this field, to use that area formula, which is pi r squared, and as it is a semicircle, of course, the answer would need to be divided by 2 after applying that formula. But there we go, that was a functional, real-life version of a circumference of a circle question.